All right, today is going to be a nice short lesson. Okay, the combination of functions. This is another one of those topics where you know how to do the 5 combinations of functions that we're going to discuss. We're going to go a step further and we're going to talk about domain every single time. Okay? So, first of all, if we are going to combine 2 functions together, their domains have to overlap somewhere. Okay? They can have the exact same domains, or they can have different domains, but if their domains are different, they have to overlap, otherwise we could not combine them. If one function has a domain of all positive numbers and one function has a domain of all negative numbers, we could not combine them because they would have nothing in common to combine. Okay? Here is the notation that you need to get used to. If I'm asking you for the sum, okay, we're used to, f of x plus g of x, but this is what it's going to look like. F plus g of x. The process, we add 2 functions together. Difference, same thing except with subtraction. Okay? F minus g of x just means we're taking f of x minus g of x. But this is the notation that you are going to see. What's next? Multiplication, the product of f and g. Okay. These 3 are very straightforward. The domain isn't going to be affected too much by the combination of some difference in products. The one we'll have to be careful with I'll just have to do that later. No, I'll do that later, but I'll have you do that at the end, okay? Do you see how it's like off? They changed my bulb and they kind of like hit it to the side, so we'll fix that in a little bit. Okay, our quotient, when we divide, we have to make sure that we aren't dividing by 0, so we will have to be a little bit careful with the domain on the quotient, but otherwise these are very straightforward. They're not going to take a whole lot of algebra to complete. So, first thing we're going to look at, an example for each of these. So I'm going to have you write down these 2 functions. Once you get them written down, I would like you to take 60 seconds and discuss with your pod what kind of function f and g are and what the domain of each function is. So write them down and then discuss the type of function and their domain. Ready, set, go. All right, Pi 4, what type of functions are these?
Linear.
They're linear functions. So Pi 3, what are their domains? Okay, since they are linear functions, each domain is all real numbers. Alright, so let's talk about the sum. Wow, that's bright. Look at that red. Is that like hurt anyone's eyes? It's like, no one else knows how bright this is, just me. Okay, you can find it. It looks orange.
You can even see like before they put any light bulb.
Yeah.
Just like
Yeah, like I used this earlier, so like between like third hour and this hour, it's like blinding. Okay, so we have f plus g of x. We are going to take our function f, and we are going to add it to our function g. Since we're adding, there's no need to be concerned about parentheses. We're just going to add from left to right. What is our resulting function? X minus 3. Jaden, what is the domain of x minus 3? All real numbers. Okay, the domain really isn't going to be affected too much by the sum. The difference of our two functions, f minus g of x. Here's where you do need to be careful. You need to take your first function and make sure you are subtracting the second function in its entirety. Anytime you subtract, make sure that second function gets put in parentheses so the negative gets applied through. This is something that may have been a struggle on number 10C on your quiz the other day. Okay. So instead we have 2x minus negative x. So we have 3x minus 7. Josh, what's that domain? All real numbers. So far, so good. The product, f times g of x. When you are taking the product, parentheses will be important again. When there is more than one term, you need to put that function in parentheses so that you can do any sort of distributing. Okay? Since we have two binomials, a lot of you like to think of this as foiling. I will usually call it distributing, but foiling is just a type of distributing. Okay? So we get 2x times 2, 2x times negative x, negative 5 times 2, and negative 5 times negative x. So our resulting function is negative 2x squared plus 9x minus 10.
I just heard like a bang. The marker.
Yeah, Eleanor, what is the domain? All real numbers. Okay? Anytime we have a polynomial function, and we'll work with polynomials more in chapter 2, but polynomial functions, their domains are all real numbers. Okay? Linear, quadratic, cubic, domain is all real numbers, all the time. Okay? Last but not least, our quotient. F divided by g of x. So we're going to take f, that's our numerator, divided by g, that's our denominator. Can we simplify that fraction?
X minus 5 over 2.
Okay, so you're saying that you want to simplify right here? Yes? No? Can we do that? Why not, Matt?
because 2 minus x is like
Okay. So here are the words that, here's the mathematical way to say that. Okay? We can only cancel out common factors. Okay? So he's saying, 2 minus x is a thing, it has to stay together. There is nothing that we can factor out of this that could cross out upstairs. Okay? If we had 2 times x minus 3 over 5 times x minus 3, then the x minus 3's could cancel and we'd be left with 2/5. See how we're separated by multiplication so that we can cross out common factors. Okay? So it's tempting, but we do have to keep our answer here. However, we need to be careful about what, Maddie?
You can't have x equal 2 on the bottom.
Okay, so our domain this time is everything except 2 because that would make our denominator 0. So let's go over that notation. This notation means everything except 2. Yes?
Can't you also write it as the domain as x not equal to?
You could, but that would not be an integral notation. And I want everything in integral notation. Okay. But you're right, that would be an alternate way of writing it. Okay? All right. That is 4 ways of combining 2 functions. What is the 5th? Huh? Yes.
I feel like
The composition of functions. Okay? Putting a function inside of a function. Here's the 2 notations. You really like this notation the best. You're probably most comfortable with that. Oh, you like this one better? Okay, all right. This is the one that you might not see as often as this one. Okay? F composed with G. F composed with G. You put G of X in for F. Whatever's on the inside, you're plugging that into the outside function. Okay? Now, you've done this before, correct? Okay. What you haven't done is thought about the domain of the composition of 2 functions. Okay? Now, let's look at what we're dealing with here. We are plugging values in to our G function. Those values, their outputs, then become inputs for the F function. Okay? So, if we're plugging values in for G, we're plugging values into our G function. Okay? And then we're plugging those values into our F function. We have to make sure that whatever we plug into G is okay to plug into the composition of the 2. Okay? So here's the definition of the domain. Okay? The domain of the composition are all the x's in G that are okay to be in the domain of the composition. Okay? And I'll explain to you what that means. All right? So we want to think about the domain of our composition. Okay? Well, we're taking x's and we're plugging them into G, and then we're taking those numbers and we're plugging them into F. Okay? So what is going to be important is the domain of the inside function. Okay? Because that's what we're plugging values into first. So we always have to be concerned about the domain of the inside function. Then we need to look at the resulting function. Okay? What do we get when we combine the two together? Okay. Then what we're going to look at is where those two domains are going to overlap. Okay. You know, if G has a restricted domain, but then we get like a polynomial out of the composition, okay, well, we're plugging into values, we're plugging x values into our G function first, and if that has a restricted domain, we can't make the composition an even wider domain, okay? So we're going to think about where these two domains overlap, okay? And I'll show you what that looks like with this example here, okay? So go ahead and write down our f and g functions. Notice that they are different from earlier. What I'd like you to discuss is, for 60 seconds, the domain of f and g. Okay, the domain of x, the domain of f is pretty straightforward. The domain of g you're going to have to be a little bit creative with. Notice that this is not a transformation of the square root of x, because there's an x squared. So you're not going to be able to think of the square root function, because it's not square root of x. Okay, so have a 60-second conversation about what you think the domains for each of these would be. 1, 2, 3, go.
Yeah.
No way. Everything great.
What kind of number do you give me?
History, describing lives, so less than yeah.
Can you wait till we're just completely done with this? Because we haven't touched base yet. Yeah. Okay. All right. Let's see. Pod 2, domain of f. All right. Who has an idea about the domain of G? Josh, is this a hand or a?
Yeah.
Okay, what's your idea?
It's everything less than 3. So it'd be like negative infinity to 3.
Like that? Okay. Michael, what was your idea?
In between -3 and 3.
Brackets or prints?
Brackets? I think brackets, yeah.
He thinks brackets. Okay. Josh, are you changing your mind?
It can't be negative.
Why not?
Because negative 3 squared would make 9, and 9 minus 9 is 0. You can't have 0 in it. Right.
Why not? Square root of a negative is imaginary, but square root of 0 is fine. 0 can't be in a denominator, but 0 can be in a radical. So -3 and 3 can be included. Okay?
That is negative infinity with parentheses number 3 in the bracket.
Okay, now what happens if we were to plug in -4? What's 9 minus -4 squared? A negative number, right? Okay, so that's why Michael's saying we have to stay between -3 and 3. If we get bigger than 3, that 9 minus x squared is going to be negative. If we get less than -3, that 9 minus x squared is going to be negative. Okay, so we have to be a little creative there. Okay, so now let's talk about the composition. F composed with G. If you want to write it like this, go for it. What I like to then do is write it as f of, and I'm going to replace g of x with 9 minus x squared. Okay? Then we're going to take that inside function and plug it into our f function. So our f function is x squared minus 9, but instead of x, we're going to write g. Okay. So then what happens? Those two cancel, right? We're left with 9 minus x squared minus 9, which is negative x squared. Okay. So now, we need to consider the domain of our composition. First of all, any questions on my blue work right here? Okay. So, the first thing we need to think about is the domain of our inside function. In this case, it is g. The domain of our inside function, we decided, was negative 3 to 3. Then, we need to look at the domain of the result. So, when we did the composition, we have negative x squared. What's the domain of negative x squared? All real numbers. Okay. However, we're plugging in to g first, and we can only plug numbers between negative 3 and 3 into our g function. So, the domain of the composition can only be where these two overlap, which would be negative 3 to 3. It's kind of nice because all real numbers, it's easy to see where that overlaps. Okay. Questions? Okay. Somebody in fifth hour asked a question that I thought was really good. They asked, so if we were to graph this, it would be a reflected parabola, but only from negative 3 to 3. And that's exactly right. We'd only have a piece of the parabola because we have that restricted domain. Okay. So this is what I'd like you to do. This is your homework. It's on your gold sheet broken up with bolded and non-bolded problems. I will make a correction. If you look at your gold sheet, it goes from 17 to 19 to 31 to 23. That 31 should have said be a 21. Okay. I'm going to give you about 10 minutes to start working on this, and then the last 6 minutes of class, we're going to get out our calculators, and I'm going to show you how to use them. Okay? So I'm going to give you 10 minutes to work, and then we'll get out our calculators.
Yeah, I get a drink.
Yes.
Thank you.